Hello guys, so welcome to our channel Roam Basic. This video we will learn how to distinguish and identify the following uh, concept on the board. So we have rational expression, rational equation, rational inequality, and rational functions. So we have here first your rational expression. So in analogy in your language or your English subject, an expression is considered to be a phrase, while the following, such equation, inequality, and functions are sentences. Or example we have here, x as a number is added by 4. So this is just an expression. But to give you an example of a rational expression, we have your numerator and denominator. So we have x plus 4 over x minus 1. Okay? So later on, I will give you the condition in identifying whether the given is a rational expression, rational equation, rational inequality, rational functions, and which are not. Okay, so first we have x plus 4 over x minus 1 as examples of your rational expressions. We have here, second example, 2x over x minus 2. Then we have x squared minus 7 over x cubed plus 2. Then, second in the line, we have the rational equation. Third, we have rational inequality. And last, we have rational functions. So, will help you understand and distinguish the characteristics of each. So a rational equation, or also known as equality, equation or equality. In an equation, we are using this symbol, the equal symbol. That's why it is called an equation, because we are using this symbol, the equal symbol. While an inequality uses symbols, of course, rather than equals. So inequality with its prefix in denotes not equal or not inequality. Not inequality. So we have greater than, less than or equal to, or we can have greater than or equal to. Okay, again, an equation uses only equal symbol, while your rational inequality uses these symbols. Okay, and your function is below your rational equation because the function also uses equal symbol. Okay, so later on we can distinguish the difference between a rational equation and rational function. Of course, it is easy for us to identify and distinguish the characteristic of a rational inequality due to its symbol. Okay, let us proceed. For us to understand it more, let us have our examples. Okay, so I will be using the same example with different signs or symbol for us to identify the characteristic. Okay, for example, we have x plus 4 over x minus 1 equals 4 is a rational equation. Okay, then for our rational inequality, if you can see, I'm still using x plus 4 over x minus 1, and this is 4, it's like this 1, but the symbol, of course, is not equal. So this is greater than. So we can read it as x plus 4 over x minus 1 is greater than 4. So again, the only difference or the most distinct characteristic between the two is the symbol. So we are using equal. This one, we are not using the equal. So in this case, we are using greater than. Next example is for rational functions. Again, for functions, we are still using this symbol, the equal symbol. So we have x plus 4 over x minus 1 equals y. So if you can see, this is equal to y, and this is equal to 4. So the difference between a rational equation and a rational function is this. A rational equation is always equal to any number or any quantity. And the most distinct characteristic is most equation, but most equation in our examples here, we are using single variables such as x plus 4, x minus 1, so we are using x and then equate it or equal to another quantity equals to 4, while your function equals to y. So an equation is always equal to any quantity, while your function is always equal to any variable. So in this case, x plus 4 over x minus 1 equals to y. Okay? So another example, we have 2x over x minus 2 equals 1/4. Okay? So that is a rational equation. For our rational inequality, we have 2x over x minus 2 is less than or equal to 1/4. Again, the symbol is equal or less than or equal to, while on our equation, we are using the equal symbol. For our rational function, we have, okay, so on our lessons, we are using this basic form of function. We have f of x. So instead of y, just like here in the first example, we will be using f of x. So f of x equals 2x over x minus 2. Okay, so on our previous examples, we are not just using f of x. So some examples, we are using g of x, h of x, s of x, t of x, and more. So these are the characteristics and ways to identify or distinguish your rational expression, rational equation, rational inequality, and rational functions. Okay, so focusing on your rational functions, and this three is stated that if a function is in the form of f of x equals to, example, you have your numerator denoted by p of x and you have your denominator as, example, we have d of x. So the first condition is d of x should not be equal to 0. Okay? So d of x should not be equal to 0. So if it is 0, then any number divided by 0 is undefined. That's why your denominator should not be equal to 0. And another condition is your numerator is a polynomial and your denominator is not a polynomial. Your numerator should be a polynomial as well as your denominator. Okay? So that is how to distinguish this for rational expression, rational equation, rational inequality, and rational functions. Okay, so we will be giving examples of how or what are rational equation, rational inequality, rational function, and which are not. On the board, we have here examples of functions, rational inequality, rational expressions, and some examples are not. So let us identify. So for our first example, we have here, we have 1 plus x over x minus 2 equals 4. So this example is identified as rational equation. Okay, going back to the definition, it is a rational equation. Okay, second, we have 5x is greater than or equal to 2 over 2x minus 1. So looking at the symbol, we can easily identify that it is a rational inequality. Okay? Third, we have f of x equals to x squared minus 7 over x plus 2 minus 3. So, symbol is equal, and we have here f of x. So, we can say that it is a rational function. So, easy. Okay, next, we have x is greater than the square root of x plus 2. So this one is not, or does not belong to any, does not belong to an equation, an inequality, or a function. Although we are using the inequality symbol, because one condition to be considered to be one of them is your polynomial. Of course, this is not a polynomial. Because a polynomial is a mathematical expression or an algebraic expression with a non-negative integral exponent, or shall we say, we don't consider any fractional exponent. So this radical denotes a fractional exponent. Okay? So integral, it means that exponent or the power of a certain variable should be a whole number, not a radical or a fraction. So this one does not belong to any three. Next example, x over 2 equals 7 over x plus 4. So it is considered as rational equation. Okay? Last example, we have g of x equals to 7x cubed minus 4 square root of x plus 1 over x squared plus 3. Again, we are using the symbol equal and we have g of x, so most of us will consider it as a rational function. But looking to this one, our numerator is not considered to be a polynomial. Because we have here a non-algebraic term. We have negative 4 times the square root of x, and this is polynomial because it is raised to a fraction or we have a radical symbol. So, this example does not belong to an equation, inequality, or a function. So, I guess you understand and you can distinguish between an equation, an inequality, and a rational function. So thank you so much and keep safe.